To run a scenario, you'll want to be in the overview page for that scenario. You can access these from the home page by selecting View and typing in the name of a scenario you've created. Once you create a new scenario and submit it, as was discussed in the previous chapter of this tutorial, you are automatically brought to the Scenario Overview page. Simply scroll to the bottom of the page and click Run Scenario Excel to generate results in Excel output format. It will take up to a minute for the application to run through the calculations to generate your MFI supply chain output file. Once the Excel file downloads, open it up to view the results of your MFI supply chain scenario. The first tab, Scenario, provides an overview of the inputs used to generate the MFI supply chain scenario. You'll recognize the product and product category, demand quantity, processes, sector efficiency potentials, and weightings. For more details on what these parameters are and how to set them for a given scenario, refer to the Building a New MFI Scenario chapter of the How-To tutorial. The top Materials Mass tab shows the inputs that are most used in the supply chain by mass. Use these results to identify which materials are consumed in the greatest mass in your MFI supply chain. The top Materials Energy tab shows the inputs in the supply chain with the highest combined direct process fuel and electricity consumption on an energy basis. Use this tab to identify the material inputs which are requiring the most energy within your MFI supply chain. Note that these values are not the same as embodied energy because they only refer to the direct energy required to produce the most energy-intensive supply chain inputs. Check out the related Total Fuel tab to get a more complete picture of energy usage in your supply chain model. The Top Materials Emission tab is very similar to Top Materials Energy, except that it ranks inputs by the direct combustion-related greenhouse gas emissions associated with their production. These values are not the same as embodied emissions as they only refer to the direct emissions at one step in the supply chain. The step-by-step emissions are aggregated in the Total Emission tab to give a more complete picture of GHG emissions in your MFI supply chain. The Electricity tab shows the total amount of electricity consumed within each step of the supply chain. Step 1 represents direct electricity used in the end product recipe, and Step 2 is the electricity required to produce the inputs in the end product recipe, and so on. Notice how the cumulative energy consumption converges toward a stable value as the number of supply chain steps increases. The Total Fuel tab shows consumption of fuel within the supply chain and disaggregates the total for each fuel by how the fuel was used. All fuel consumption values on this tab represent combustion except for the feedstock fuels, which are converted to other chemicals. Fuels accounting for less than 0.1% of total fuel consumption are excluded. The emissions values on the Total Emission tab represent carbon dioxide, methane, and nitrous oxide emissions from fuel combustion only. 100-year global warming potentials were used to convert all emissions to kilograms of CO2 equivalent. Fuels accounting for less than 0.1% of total GHG emissions are excluded here. The Transportation tab shows details of the fuels combusted for commodity transportation. Transportation was calculated on a sector level using 2012 Commodity Flow Survey data from the U.S. Census Bureau. The Electricity Grid Mix tab, the final tab in the Excel output, gives an overview of the assumed electricity grid mix, showing the amount and percentage of total electricity generated from each generation source and corresponds to the electricity grid mix chosen when building the MFI supply chain scenario. If you need further assistance or have any other questions about using the MFI tool, please feel free to reach out to the MFI team by emailing mfi@nrel.gov.